Okay, so it turns out that there's three different types of transformations for outputs. Remember, our output is usually y. And under our definition, under the most basic circumstances, y is x squared. So this can be treated as an output. All right, you give me an x and square it, right? I'm giving you the output for this function. So we're going to be manipulating x squared as opposed to manipulating x like we did in the first video. So how do we get this? Well, first of all, we can simply manipulate it by subtracting something from x squared. This is very different than what we just did, right? This is not equal to x minus 2 squared. Here, this is being subtracted from the input, and we've already seen that this causes a shift to the right 2 units. Here, what we're doing is subtracting 2 from the x squared. So we are truly taking the outputs of this function and subtracting 2 from that. So what's the new function going to be? All right, so this y and this y are a little different. So here's the original function. This new function is x squared minus 2. Again, let's do some point plotting. Let's kind of figure out what happens there. Sorry, I'm kind of losing my voice there. So if I put in a negative 2, we get negative 2 squared minus 2. That's 4 minus 2, which is 2. All right, so there's the output of this new function. If I put a negative 1 in there, we get 1 minus 2, we get negative 1. If I put a 0 in there, we get negative 2. If I put a 1 in there, we get a negative 1. And if I put a 2 back in there, we get 2. All right, so we know what this basic function looks like, right? There's its graph. So in its basic form, right, it's a nice parabola at 0, 0. And this new one, where I'm subtracting 2 from the x squared, let's point plot it and kind of get its relationship with the original. So we have negative 2, 2. We have negative 1, 1. We've got 0, negative 2. 1, negative 1. And 2, positive 2. So here's our parabolic shape. Again, the parabolic shape is very similar to just good old x squared, but you can see what's happened is it went down. And how far did it go down? It went down 2 units. What used to be a vertex at 0, 0 is now a vertex at 0, negative 2. So everything has been shifted downwards. So this is a shift down 2 units. If you wanted to shift down more, right, if we were graphing x squared minus 3, then this graph would be a shift down 3 units. And again, I can graph that really quick. I would just take my x squared graph, move the vertex down to 0, negative 3, and then everything else kind of falls into place. All right, so that's how we create a shift downwards. We subtract something from the x squared. So you can anticipate, how do we get something to shift up? Well, how about we add something to x squared? So again, let's just, we'll do this the ground and pound way to see it, and then hopefully you'll see that your instincts are serving you well. So we got, again, putting in a negative 2, negative 1, 0, 1, and 2. If I put in negative 2 squared, we get 4 plus 2, which is 6. If I put in negative 1 and square it, we get 1 plus 2, which is 3. If I put in a 0, we get 0 plus 2, which is 2. So we've got some data points. If I put a 1 in there, we get 1 plus 2, which is 3. And if I put a 2 in there, we get 4 plus 2, which is 6 again. So when we go plot this guy, right, so there's the grid. We've got negative 2, 1, 2, 3, 4, 5, 6. We've got negative 1, 1, 2, 3. We've got 0, 2 on the graph. We've got 1, 3 on the graph. And we got 2, 6 on the graph. So everything is there. There's our parabola. We see the symmetry. But now the graph has been shifted up, right? The vertex is usually sitting here at 0, 0. But it's now been shifted up 2 units. And so that's how we do. So if we add 2, we get a shift up 2 units. And if we wanted to do a shift up 3 units, then we would just basically graph x squared plus 3. And that would basically shift the vertex up to 0, 3, and then everything else would have its basic shape that the normal x squared graph would have. So there's our first relatively easy transformations of outputs. We basically add or subtract something to the x squared. And again, don't confuse that with adding or subtracting something to the input and then squaring it. The x squared's already been done. You can kind of even see me doing that in my calculations. I square and then subtract, as opposed to in these calculations we subtracted first and then squared. Very, very different dynamics. But it basically simple shifts up and down. Alright, so next transformation for outputs is coming in the next video.